Okay, good afternoon. Okay, we start our final exam revision with this exam revision exercise. Okay, do number 1. Now, show me the drawing first, okay? So you should be able to draw in 3 minutes. Drawing. If your drawing is accurate, then most likely your answer will be accurate, okay? Okay, done. Okay, remember this is a structure. Okay, a structure is basically a group of common items. Okay, and the purpose of structure is so that I can group many common variables together. Now, in this case, you only have one items, but actually, in a structure, you will have multiple stuff. For example, like age or name. So all can be grouped together inside a structure. Clear? So a structure is like a box inside a box, inside a big box. Okay. So this is just a definition of a structure. The real structure is created once your program execute this line. So it says lecturer A. Lecturer A means you are creating a real lecturer structure. Okay. So A. Now the address already given 1111. This one is 2222. And then inside this, there's another box, which is salary. Okay. I just put SAL for salary. So that complete this part. Any question? Any question? Okay, and then star B, the star B means pointer B. Okay, single pointer. Now the address already given 2222. And then it's a pointer of type lecturer. It means you can only point to this lecturer structure. Clear? Then double pointer C. So double pointer C, type lecturer. And then the address already given 3333. It means you can only point to single pointer B. Clear? Which one? A. A is a structure. So a structure is a big box, and inside the big box, you have the actual data, smaller box. Okay, clear? B is a pointer, C is a pointer, not a structure. Okay. Structure can be inside structure, but this one is not structure inside the structure. This one is data or items inside a structure. Clear? Okay, and then A dot salary equal to 1000. Now, if I want to access something inside a structure, this is how you access using dot. So A dot salary 1000. Clear? Okay. I cannot say A because A is a structure. Okay. I must say A dot salary. B equal to new lecturer. Now remember, new lecturer will create a new anonymous structure. Okay. No name. So I simply put X. So this is address of X. Salary. Now it doesn't need a name because whenever you create a new structure, you must assign it to a pointer, B. So what will happen is the address of this new structure will be put inside content of B. So this address of X will be put here. Clear? Automatically. So what will happen? B automatically points to X. Okay. B arrow salary equal to 2000. Now this is another way to access the content inside this using a pointer. Okay. So B arrow. Now once you put B arrow, at the end of that arrow must be a structure. And you must choose which item you want to display from that structure. So B arrow salary 2000. Clear? C equal address of B. So you put a content of address of B into content of C. So address of B is 2222. So you put that 2222 here. So what will happen? Automatically C points to B. Last one, A equal to star star C. What is the meaning of star C? No. What is the meaning of star C? What C is pointing to? Okay, so what is C pointing to? C is pointing to B. So this is B. Clear? So star B, what is star B? What is star B? What B is pointing to, which is? What B is pointing to? X. So this is X. So what is the meaning of A equal to X? Now, what is the meaning of A equal to X? If I say J equal to 5 and then M equal to J, what will happen to M? What will happen to M? The value of 5 is copied to M. Same thing here. This 2000 will be copied to A. Okay? The value inside this will be copied to A. So now A becomes, the salary in A becomes 2000. Clear? Remember, you can only do structure equal to structure if they are exactly the same structure. Okay? Otherwise, you will get error. Clear? Okay, now you have all this diagram. Now you should be able to answer all of this. So in 3 minutes, answer all of this. Altogether here, there are 21 questions. Okay. Now, question like this most likely allocates 10 to 12 marks. 10 to 12 marks means you need to answer 10 to 12 marks, something like that. 100. This one? You don't say pointer, pointer C, because C is already a pointer. When you declare this, C is already a double pointer. Okay. So this is star star C. Okay. So star C is what C is pointing to, which is B. So this is actually B. Star B is what B is pointing to, which is So what B is pointing to? Star B is what B is pointing to. X. So A equal to X. Meaning you copy the content of X into content of A. Okay, 3 minutes. If your drawing is correct, most likely your answer will be correct. All the answer is inside that drawing. Done? Okay, so what is address of A? 1111. Remember, the address will not change, okay? No matter what. What is A? What is the meaning of A? Content of A. So, what is A? 2000 is the content of salary. 1000 is no longer here, it's overwritten by this. Salary is not the content. Error. Why error? Why error? Because you try to display a structure. You cannot display a structure. You must tell which item inside the structure that you want to display. Clear? Okay. So structure is just a group. You need to tell what are the things that you want to display. A arrow salary. A arrow salary means there's arrow going out. There's no arrow going out in A. Okay. So error. A dot salary. A dot salary 2000. Okay, that's how you properly access A dot using dot for the structure. 2000. Star A. What is the meaning of star A? What is pointing to? A is not even a pointer. Okay. Error. Star A, arrow salary. Error. Because star A means what is pointing to is not a pointer. Same with this, it's not a pointer. Error. Any question? Okay. Next one, address of B. Address of B. B. What is the meaning of B? Content of B. So what is content of B? Address of X. Okay. B arrow salary. B arrow salary. B arrow salary. 2000. Clear. So you can see there are two ways for me to access the item inside a structure. Either I use dot, I will use arrow. If I'm at the structure, I will use dot. If I'm coming from somewhere, I will use arrow. Okay. B dot salary, error. B is not structure. If you put dot here, B dot salary, it's not salary. Okay. Error. Star B. Star B. Star B. What B is pointing to? Where is B pointing to? Where is B pointing to? X. So this is as if you say, what is X? What is X? What is X? Error. Why error? It's a structure. Same like this. You cannot print a structure. Error. Clear. Star B arrow salary. Star B arrow salary. What is star B? What B is pointing to, which is X. So star B is X. So this is as if you're saying, what is X arrow salary? What is X arrow salary? Error is not arrow. Okay, so error. Star B dot salary. This is X. X dot salary. X dot salary 2000. Okay, next one. Address of C. Address of C. 3333. C. Content of C. 2222. C arrow salary. Error. C arrow salary. There's no salary here. C dot salary. C dot salary. Error. C dot salary. There's no salary here. And C is not a structure. Star C. Star C means B. So what is B? Address of X. B is address of X. Star C arrow salary. B arrow salary. B arrow salary 2000. Same with this. B arrow salary 2000. Star C dot salary. Star C dot salary. What is star C? B. So B dot salary. B dot salary. B dot salary error. Same with this. Clear? Clear? Any question? Question? Any question? Okay, if no question, then do the next one. ABL, question 2. Draw ABL 3. Okay, so first, number 5. And then 15. Number 15 is greater than 5. So 15 is to the left of 5. And then 16 here. Is this balanced or not balanced? Balanced or not balanced? Not balanced. Where? At 5. So indicate 0, 2, and then rotate. Okay. There's no problem of inside out because inside is lesser than outside. Okay. So rotate 15, 5, 16. Clear. So done, done, done. Now add 7. So 15, 16, 5. 7 is lesser than 15 and then more than 5. So 7 is here. Is this balanced or not balanced? Still balanced. So add 8. 8 is lesser than 15, more than 5, more than 8, and more than 7. Is this balanced or not balanced? No. Where? 5 and 15. Clear. And the rule is we rotate the lower one, which is 5. So rotate. No inside outside problem, so I can just rotate directly. Clear? Okay. Okay, next I add 12. 12 is lesser than 15, more than 7, more than 8. So 12 is here. Is this balanced or not balanced? Where? At 15, 3, 1. So rotate to the right. But we cannot rotate because remember, this is the border. Inside is more than outside. Okay. So I need to rotate this way. Double rotation. So first I will show this rotation, the first rotation. So this is after this first rotation. Then I need to rotate up here. And then what happened to 12? It will jump to the other side. Clear? So before, after, before, after, before, after first rotation, after second rotation. Okay? If it doesn't change anything, no need. Any question? Any question? Okay, do the next one. Number 3, B3. Remember, in B3, you cannot do if there is no order number. Clear? So you must know the order number. Then only you can do. M equal to 3. Done? Okay, done? Okay, because m equal to 3, what is the meaning of m equal to 3? What is the meaning of m equal to 3? Maximum, 3 children, 2 keys, okay? So when at 1, I don't need to draw. I know nothing will happen, okay? It has not reached the maximum. Okay, then 2. 2, I know now I've reached the maximum. So 2, 3. Remember, you put 3, 2, that's error. Okay. And then 8. So 8 cannot be added. This is full already. So 8 is supposed to be here. So 3 is the middle. So 3 will go up. This one will split. Okay. So 3, 2, 8. Clear. Okay. And then 1. Add 1. I cannot add here. This is after the split. So I will create new one. Now 1 is smaller than 3. So 1 will join number 2. Okay, and then 7. 7 is greater than 3, so 7 will join number 8. Okay, then 4. Now 4 is greater than 3. So 4 will join 7 and 8, but this is full already, and 4 is supposed to be here. Okay, so 7 is the middle, so 7 will go up, join number 3. So 3, 7. 1, 2. Then 4 and 8. Okay, any question? Okay, and then we add 5. So I need to redraw this. Okay, so 5 is here. Okay, and then 6. So 6 is between 3 and 7. It will join the middle one. So 6 here. So 5 will go to top, join this, but this one is also full. So 5 is the middle. So 5 will go up. Done. Any question? Any question? 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 Okay, if no question, then you can take your break, come back at 5:05. Okay, let's continue. Okay, now do this GCC matrix and link a GCC list. Now do both directed and undirected. Directed, undirected. So 4 diagrams altogether. Clear? 4 diagrams, 4 minutes. Both the matrix directed and undirected. GCC list also one directed, one undirected. Done? Okay, directed first. Huh? Okay, remember for directed, I will only count if it is pointing to something. So that something will be put inside the list. Okay. So 1 is not pointing to anything. So there's nothing in 1. Clear. 2 is pointing to 4 and 6. So 4 and 6. The rest are zeros. 3 is pointing to 2, 6, and 5. 2, 6, and 5. The rest are zeros. 4 is pointing to 5 and 2. 5 only. 5 is pointing to 1 only. And 6 is not pointing to anything. 0. That's it. For directed. Clear? Now, if I'm doing the adjacency list, 1, 2, 3, 4, 5, 6. So I can refer to the matrix. 1 has nothing. Okay. So this point to null. 6 also point to null. Clear? Now 2 should have 4 and 6. 4 and 6. 3 should have 2, 5, and 6. 2, 5, and 6. 4 points. 4 should have 5. And 5 should have 1. That's it. Any question? This is for directed and directed. Okay. Any question? Any question? Yeah, I cannot test for symmetrical because it is not undirected, it's directed. Okay. The symmetrical is for undirected. Okay, now we go to undirected. Okay, undirected. Now I will do on the same matrix. Okay. Now for undirected, you don't care about the arrows. As long as it's a link, it's considered as 1. Okay. So number 1 has link to 5. So this will be 1. Clear. Number 2 should include number 3. Number 3 completed already. Number 4 should include number 2. Number 5 should include 3 and 4. Number 6 should include 2 and 3. Okay. Okay, now because this is undirected, I can check whether they are symmetrical or not. Okay. So check. Okay. Symmetrical. Clear? Now for adjacency list, same thing. I just add the member that is present in my undirected matrix. Okay, so 5 need to be added here. Then a 3 need to be added for 2. 3 is completed already. 4 need to add number 2. 5, I need to add 3 and 4. And 6, 2 and 3. Done. Any questions so far? Any question? 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 Okay. Okay, if no question, then we will do the one exercise that we skipped last time. Okay, 3 exercise 2. This one. Now there are 2 items here. We just do 1. Okay. So if you know this, then definitely you can do this one. Okay. Now I want you to give me the pre-order, in order, and post order. The sequence. And a pre-order means visit, left, right. In order, left, visit, right. Post order, left, right, visit. So what does it mean? So in pre-order, once you reach any nodes, automatically you visit. Okay. In order, you must visit all the left children first. Then only you can visit the parent. In post order, you must visit all the children. Then only you can visit the parent. Okay, there are 3. You have 3 minutes. Okay, just a sequence. Done? Done? Okay, so pre-order. Visit. Go to the left, visit. 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 Up, down, visit. Up, down, visit. Up, down, visit. Down, visit. Down, visit. Up, down, visit. Down, visit. Up, down, visit. Down, visit. Up, down, visit. Up, down, visit. Down, visit. Done. Any question? Okay, in order. So in order, you must visit the left children. Okay. So cannot, left children not visited. Cannot. Now is my first visit because there is no left children. Up, now I can visit B. Down, I can visit C, no left children. Up, I can visit D. Down, no left children, can visit E. Up, now I can visit H. Down, cannot visit J. Up, now I can visit K. Up, now I can visit L. Down, cannot M. Up, N. Cannot P. Then Q. Then R. Up. Then S. Then there's no left, so T. Then Z. Done. Any question? Post order. Remember, in post order, you must visit all the children first. Cannot A, can, because there is no children. Okay. Cannot. Yes. C. Now only I can visit B. Clear. Up, cannot. Down, E, no children. Up, now I can visit D. Up, cannot, J. Then K. C, cannot, M. Up, cannot P. Up, cannot R. Up, H. Okay. This is not visited, right? So after R, Q. Then N. Then L. Then H. Up, cannot Z. Up, T. Then S. Any question? Okay. Okay, let me go through your test revision notes, final exam revision notes, course revision notes. Okay, lecture with one problem algorithms program. Basically, you just need to know the difference, okay? The difference among these three. Now, week 2, week 3, week 4, week 5, these are heavy in coding. Clear, okay? They are heavy in coding. So, and you can see the word code. So, meaning you need to know the code. Single English, double English, circular English, stack, and queue. Okay. This final code here. Clear. Now, there's also a theoretical question. For example, like here, advantage, disadvantages among the three. And also for your stack and queue, you have question like you need to know the difference, okay, between stack and queue, like the behavior, first in, first out, this kind of thing. Okay, so that's the theoretical part. Now, there's also this tutorial week 2. This is the exercise similar to the one that we did just now, the first one. So that's considered theoretical as well. Okay. Other than that are all coding. Now, if you want to start from scratch, which you don't have much time, you can still learn the drawing. Okay, if you don't want to remember, that's why you learn to draw, so that you don't need to remember all the code. Okay, but you need to go through the sequence. Lecture 1 first, lecture 2 first, tutorial week 2, lecture 3, tutorial week 3, lecture 4, tutorial week 4. Okay, then only you can understand the drawing. But most of your question will come from week 6 until week 13. Okay, the majority of the question. You have coding, but majority will be week 6 until week 13. Okay. Now in week 6, you need to know bubble selection and merge. These are the three sorting that you need to know. Okay. There is no code here, so you don't need to know the code. You just need to know how it works. Okay. Which one is faster? You can compare using the big O and this kind of thing. And then week 7 is recursion. Now notice that there's the word code here. So you need to know the factorial, Fibonacci, recursion, and iteration. It's just a short code. Okay. And for recursion, make sure you know the pro and con of recursion versus normal iteration. Now, week 8, these are basically what you learn in your assignment. Clear? So I will not go through this. Basically, if you did your assignment well, then you'll be rewarded with this. If you didn't do the assignment, everything you pass to your friend, now you pay the price. Okay? Clear? So this question is not much different from your assignment question. You can run, but you cannot hide. Okay, week 9, 3 terminologies. These are 3 terminologies like node degree, 3 degree, height, okay, those kind of things. How many the parents number, children number. And then binary tree representation, why we use pointer instead of arrays for binary tree. And then week 10 is the one that we did just now, prefix, pre-order, in-order, post-order. There's a word code here. So you need to know the code for the pre-order, in-order, and post-order, the short code, okay? Why that first traversal better than Brad's first traversal? Why we go up and down rather than left and right, left and right? And then for ABL3 and B3, make sure you know why. Okay, why we use ABL3, why we use B3, okay? And then the 3 insertion mechanism is the rotation and the splitting. Clear? For the graph, the one that we did just now, adjacency matrix and adjacency list. Make sure you know the pro and con of both. Okay, why in certain cases matrix is better than list, in certain cases list is better than matrix. Okay, and then the graph, Kruskal, and Prim. That's all. See, very short. Any question? Now the format of your test. Now the mock exam is it's given to you. You have 6 questions altogether inside this. Okay. For your test, you have section A and section B, or is it section 1 or section 2, something like that. Okay. So 3 questions in A and 3 questions in B. So you need to answer all questions in A and choose 2 out of 3 in B. Clear? Now this type of question, you can see this question number 2. 17 over 20 marks are all coding. Okay, this type of question will be in section B. So you can choose not to answer this type of question. Clear? It's optional, but remember it's not everything. Okay, you still have coding sprinkle little bit here and there. Okay, for example, like this question, as you can see, this one, right? 4 marks. Okay. Or this one, Fibonacci stacks. Okay. There's also some little bit of coding, but the majority is in one question where you can opt not to answer. Clear? So up to you. For example, in this case, even if you don't answer all the coding, so you don't answer this, you don't choose this, not a problem. And if you don't answer this, for example, this one is only 4 marks. This one only 10 marks. So you still have 86 over 100. Clear? Any question? Any question? Question? Okay, for your coursework mark, your video assignment, 20%. This one, the marks, I will post this weekend. Okay. Your test 2, hopefully you will get on Monday. Okay. 10%. So all marks will be posted to your times. Clear? Any question? The subgroup will be next weekend. This weekend this Friday is the submission, right? Yeah. So you'll get in 1 more week. Any question? 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 Any question? $40 over 100. 40 is your exam passing mark. Course passing mark is 50. So exam plus your coursework must be above 50. 50 or above. Clear? So if your coursework is, if your exam is 40, that will be 12 marks. And if your coursework is 38 over 70, then pass already. Most of you will get at least 40 for your coursework, okay? Because most of it is group work. So it's not the coursework you need to worry, it's your exam. It doesn't matter whether your coursework you get 69 over 70. If it's less than 40, you fail. Okay? Clear? Any question? Okay, if no question, I will give you your attendance code. Okay, once you key in the attendance, you can leave. Okay, thank you very much. Good luck. Wait.